And Rajvi, take it away whenever you are ready.
Is it recording?
It says that it is.
Okay. Um, so our goal is to ensure every algorithm we put in, we incorporate into like Bilayers CI/CD can be executed via command line interface and packed within a Docker image that encapsulates all dependencies and execution scripts. So in case if the algorithm doesn't offer a command line interface, we need to write one. If it has, like Cellpos have a really good command line usage, and we fortunately have the Docker too, so you can just start writing stuff from step 3 um, till interface. But in the StarDist case, we don't have, so we are gonna write like CLI wrapper around it, and then Docker also. So uh, I hope you guys can see my code screen. Okay. Um, I am
If you
creating a
could, if you could increase the size just one or
yeah,
two notches.
yeah. Wait. Um,
Yeah, that's good.
yeah. Um, so this wrapper will accept arguments like input paths, parameters, output location using standard libraries such as Python's argparse. But before that, like how would you choose like what parameters would go into uh like uh, in like CLI wrapper. So a good starting point would be following documentation, and this is the StarDist official GitHub repo. Uh, since we are only as of now going for inference stuff, we can look into this function. But then Beth suggested we already have run StarDist CellProfiler plugin. So the good starting point for me would just like expose all the parameters that we have exposed already in our CP plugin. So I'm going to so that was my starting point. Now once you would start like by layers, you would have this folder structure. You just need to as of now look into algorithms folder, which is under like source folder algorithms. I am creating, usually you would create a branch from main, like check out a branch from main. But since I have some stuff in my current branch which I need, I am like checking out uh, a branch. Okay, here. Um, now, um, Now since I am in the branch, I would make a folder. Usually, naming structure is if you are doing inference, you put in algorithm's name and then inference, or training, then inference. Instead of inference, you put training thing. Um, and already I have StarDist inference things here, so I would just, for sake of this tutorial, I would we are developing StarDist thing only, but like I would rename it as Star Inference. Then um, essentially, I we should write stuff, but I'm copying some of the stuff from like StarDist inference thing. First of all, we are writing a super small py file, which I would copy from here, but would explain alongside. Um, so uh, this the starting point would be here. Uh, this line ensures that the code inside this block only runs when the script is executed. Um, an instance of argparse.argument parser is created with a minimal description. And then we are adding several arguments, command line arguments via add argument method. I have here made like two arguments. mandatory. One is model type and another is input folder. You must have like either 2D or 3D model chosen, and then input folders, um, eh, the path of input folder, um, um, and a couple of parameters, probability threshold, non-maximum suppression thing, tiling details, and if you want to save probabilities or use GPU, those kind of flags. Then parse args method would read and parses the argument supplied by the user when running the script. And then it call like main function here. In our case, it is like star inference. That would which carries out the segmentation for the specified parameters. Um, Now, going into the function, firstly, it checks if the GPU usage is requested. If yes, it queries TensorFlow. It queries the TensorFlow for available GPUs and optionally enables memory growth. Now, if the output folder is created, if it doesn't exist, it creates one. Then the function scans the given input folder for image files with common extension. It deliberately skips the files that already contains segmented or probabilities in their name to avoid. We have like output folder as path, but in some scenarios when user would like give output folders path similar to input folder, then just to avoid redundant processing um, of the output of the current given output, this is just a sanity check for that. Then it would go into like model loading. So from the chosen model like 2D or 3D, it loads the appropriate StarDist model. Then it prints the class being used, and tiling parameters are combined because the predict instance function needs it in list. Essentially, this function is kind of copied from CP plugin. So if save probabilities are not requested, then uh, you just only load the stuff for data. And if probabilities are also desired, then essentially you get data and probabilities uh, by passing all these parameters. Now, um, mm, and the segmentation probability outputs are stored in specified output folders. And throughout the process, function prints status messages for like debugging and logging process. Now,
Before we move on, is it fair to say that like here there's a lot of sort of details of the specifics, but the average person sort of hopefully won't need to sort of understand deeply what all of those things do, because that's part of what Bilayers is going to help them not have to do, or because there will already be documentation or a container that they can usually pull from, right?
yeah, that's correct. But in case if they are supposed to write the CLI wrapper also, how we have developed it, I'm just like going over the stuff,
Mhm. Yeah,
what I have kept in mind while developing. So maybe
yeah,
in case of
absolutely. And again, like this is less than 200 lines of code, which feels like for access to a new algorithm in many other tools, a very reasonable amount of code to write.
yeah. So now once we are done with this thing, we need to go over Dockerfile. So mm, I'm not going over slides also because it has some of the information which I'm saying out. Do we always need one Docker file? Again, no. If we have a Docker file that has pre-configured Python environment with all the algorithms dependencies and algorithms CLI executable code, then definitely we can use that. But for starters, we don't have. So again, I'm making a Docker file, just copy pasting stuff from already built one. And here, since our file names are like star inference, I would and then we started off with Python 3.9 as a base image, because it's lightweight, which means like smaller image sizes and like you can download it faster. And also it comes with Python pre-installed, so we don't need to do extra steps to install Python or configure Python. But also you can start with Ubuntu. It's a great practice. You could develop your own virtual environment and then later install Python. But one of the problems that comes with it is like you need to make sure that your virtual environment persists to the next Docker file, because essentially Bilayer would wrap a Docker which uses base image of the algorithms Docker. So if you are into that problematic situation, we on the documentation you go to choosing the right base Docker image, and we have explained how to configure that. Then again, I'm just making sure I don't have any StarDist thing here, otherwise it would um, give me errors later. uh, Everything should be star inference or something like that. So now it seems all right to me. One of the error that I faced while developing this was okay, later to error. First, like before that, um, once you are done with these two steps, you should have a practice to uh, lint your code. So I'll go to my star inference um,
And what does linting
folder.
code mean?
Sorry, what?
What does linting your code mean?
So just checking if has um, pra- that has like correct practice of no extra white spaces, or uh, if there is like extra line in the end. For example, if I don't do this, then it should give me one error. Oh, oh, sorry. Uh, wow, weird. Um, it's like just checking your code if it follows the good practice, which is
I think you were just forgetting to save it, Rajavi.
sorry, what?
You made the change to the file, but you didn't change it. I mean, save it.
Oh, no, weird.
Yeah.
Um, Okay, but I have one of the errors picture over here. So something if you find like, oh, rough check is failing, that would give you error like this, and then you fix it. You can use rough check fix for fixing the stuff, which automatically mostly fixes your most of the stuff, but in some cases it doesn't. So you need to manually go to that page and fix it. And now since our Docker file is also written, I would just like build it and publish it, and then move on and then jump on to like
That's
sharing more about
code
the
telling me my code is too complex. My code is very complex. Code linter.
uh, okay, and then push it. Um, so yeah, since it's building, I would tell like what error I went in whilst building the Docker file. So during the build, I encountered an error where G++ compiler wasn't available. So I resolved this by ensuring that our Docker file installs G++ along with other necessary system dependencies. So sometimes you get to know during build time, oh, such stuff aren't present. Let me install this. And sometimes I mean, I didn't know like G++ also needs some other stuff, other packages along with that. So I was like looking on Reddit, and Reddit, I'm like lately hooked onto Reddit, which gives the almost very exact question which you have in mind, and then people have responded very nicely. So I think for those errors, maybe Googling helps. And then I think it's built now. So hitting on to like config file. Um, so this is the step 3, where some of the users would directly start off with this because they have pre-built Docker image. Um, yeah. So now on the documentation, you would see what a config file must have. So all these high level sections. So I'm essentially copying that and like pasting, but also some of the parts I would like copy paste from our StarDist inference thing. Um, okay. Mm. Yeah, so this is on the right side, I'm writing the Docker file, and this is the already built one, just because I don't need to go back and forth to the stuff, and it's like a lot. It should be in time. That's why I'm just like doing this. So tool name, star inference, category, uh, object processing. There was this whole Excel sheet which most of you have looked into, and then suggested what should go in the inputs and what should come out. So categories comes from that. Um, so essentially StarDist, because then some number, I am not going to look into the license and stuff details, but I think I know this is BSD3 clause. So um, uh, where now the Docker recently we pushed, we are just putting those details. It was Rajavi Shah's org name star tag 5.0.0, and then platform was this machine. You can find all those information, platform information here also. Um, Here, um, algorithms folder name, star inference. Um, then script would be translated to CellProfiler plugin thing. So make sure you name this correctly because it translates to class name, and then module is which module it imports. And then how would you run your script? So essentially Python star inference.py. Um, now, okay. Um, this, oh, sorry, I already did that. And now moving to inputs. So essentially there are two inputs thing. In our case, for example, if you see, either we want user to input their custom folder, custom model, so which would be uh, custom path. So essentially, we need a directory which holds all the training material in that, and any input folder which has the images which needs to be segmented. So in our inputs, we gonna have two things. So also, uh, going back to documentation, when you see how you write inputs, inputs are categorized essentially into 5 categories, and then this is the basic skeleton structure of inputs. Now, if, for example, my input type is image, I should essentially copy this and paste it over here. But just for like saving my time, I would copy input, first input from here. Um, so it names input images, type is image. So I'm not super sure if they are like grayscale and color only, but they could be binary. So it's best bet on the algorithm, I mean the developers who are writing the spec, which in all you think subtypes can be included or supported by StarDist. So you can see here, we are currently supporting for 4, but may add more if there are. Description, any CLI tag, which is input folder in our case. CLI order supports whilst you're building your command line argument, at what position you would like to see this tag to be. Um, I mean, essentially the tag and the argument, respectively. So default could be either directory or single. If I remember, it's yeah, single or directory. If it's just file or it's a folder, then directory. Uh, is this thing optional? No, you need to have the stuff format. It supports this type of images. Folder name, Bilayers, input images. This is essentially you need to remember when you are volume mounting stuff for Jupyter Notebook. Otherwise, Gradio, it takes care for itself. File count multiple images are like can be passed. Yeah. Section ID inputs mode beginner. Uh, if the image has depth, time points, styled, or pyramidal, I've given true for everything. Now, custom model path. Um, so similarly, if this is just the type file, um, and there are, so since it's like type file, there are no extra flags needed. Um, essentially, you would have, okay, here, what and all arguments would be needed by if the type is file in input section. So label, description, CLI tag, order, those are essentially the similar stuff. Now to outputs. Again, it would output 3 things, which would be segmented images, then probability image, which would be TIFF, and the probability array, which would be NPY file. So first is like segmented images, then you type in which flag affects this output, its output folder. Uh, Other stuff is normal. Um, I am copy pasting similarly image, I mean probability image stuff, and I won't go over the similar types again. If it's like new type, I would explain what it takes. Um, so it's array, then you don't need any extra flags. Just this normal flags which are present in this main section, those are sufficient. And what array things are doing are essentially commented here, like for example, default is like single or dictionary. So you could choose those are two options to choose from. So here this is also affected from save probabilities. Default could be directory because folder, it's essentially a folder, that's why. Format npy, mode advanced. um, yeah, and then coming to parameters, um, model type was one parameter, which could be essentially 2D or 3D. So okay, there are just two options, so I have to think like how would I choose, because my parameters have, we support like seven parameters, 6 or 7 parameters. If it's like radio, it fits in radio drop down checkbox. So essentially it could fit in like radio and drop down thing, because you can provide two options, either 2D, I mean two options, 2D and 3D. But I would like to go with radio. So those radio type in here would be translated to radio buttons in Gradio app, and then also radio buttons in Jupyter Notebook. Um, so I would copy paste that. Um, so yeah, model type, flag, and then it's fine if you don't type in CLI order, but also just and if it's, so all the parameters also have a basic skeleton structure, but if in case your type has if in case your types are this, you need some extra flags. So for example, radio, you need extra flag as options, which would have label and value as their I mean, which would also hold labels and values inside those things. So you would write this extra flag apart from the basic skeleton structure of parameters, if your type is radio. Now uh, yeah, nothing else, like it's all similar structure than com like inputs, outputs, parameters, display only. Just you need to go to documentation and see if there are if my type is something, then do I need any extra flag, and then if yes, then how can I write it. Essentially we have written all the skeleton structure for every input type, output types, and parameters type. So maybe you can easiest would be to copy paste from that. So uh,
And
again, model
Rajavi
name.
also made at one point a ChatGPT model that you could pass in help text and it would do that. And we also want to do things like make like a Streamlit app or something that could automatically say let you put in response to like drop downs and things what your things are, and it would write the config for you. She's already done a fantastic job of making it easy, but we want to make it even easier.
That documentation is an incredible starting point. I am, heart eyes about those docs.
Yeah. So now moving on to model names. I just copy pasted this because it's very also hard to write in as of now. Um, no spelling mistakes are encouraged because it would later cost you something. So again, it's radio, so not going over through the same stuff. Now you need to give output path, which is essentially text box. Um, text box doesn't have any extra flags if that is okay, specifying folder name. So it has one extra flag, output does set true. So in case you want to say if the output directory, do you want to change it or then say true. Otherwise, it would be visible to the user, but he won't be able to um, um, change that folder path name. It's essentially for user to be aware that, oh, this is where my output would live. So he can check it. Then um, float and integers are one of the easiest things. So they don't have any extra flags. Just basic parameters is fine. Um, Everything has essentially name, type, label, description, default, um, and all the stuff which you can see. So uh, have copy pasted until here, and then integers. This is for tiling purpose. So if you give default as 1 1, the whole image would be taken. But if you give like 2 1, then it would be cut horizontally. Horizontal tiling would be done. So sticking with the default things as of now. And then last would be the checkbox stuff. So there are two flags, save probabilities and use GPU for which would be like uh, which could be like a checkbox that would be translated in checkbox in Gradio and Jupyter Notebook, both the sites. And display only would follow the same structure as parameters. The only thing is user won't be able to tweak any of the parameters on the display screen of Gradio and Jupyter. And also those wouldn't be translated while executing a command line argument. So it's just for like viewing purpose, nothing else. So essentially this is my config file. I am just checking if I have copy pasted all the stuff with star inference name. It shouldn't include StarDist as of now. Otherwise, yeah.
Rajvi,
Mm-hmm.
do you have a specific example for when you would use the display only, like when that would be a helpful thing?
Yeah, so in the case when I just need to know what my output path would be. For example, if I wouldn't have made this flag over here, output folder, and I would always write my output folders in a folder name, output StarDist, which would be like an internal function or internal operation of this function, star inference. So we are not like penetrating in and tweaking the output folder path name. So then for a user to know, it would be great to put in a text box type and which says the output folder is in this path. So essentially you could just check that.
That makes sense. So like anything that would be helpful for a user to know, but that you
Yeah.
don't actually want to make configurable.
Yeah.
Okay, thanks.
So now after like writing the config file, you need to make sure that your config file is in compliant with Bilayers spec. So in case if you are so we need to check if that is correct or not. So we would validate our config file with bilayer spec. So, and we have used linkml to write our specs configuration. So here it's like linkml validate. The schema is in this thing, validate schema, which are our rules, and then target class is spec container, which you don't need to worry about, and then which file you want to like check against this Bilayers rule. So okay. So essentially Docker image is not like this. It's like Docker image. So now it should pass. Yeah, I forgot to save that. That's why that came in. Now in case if you are tweaking our spec, for example, some users can also request you extend your spec file. So our spec file is living in the test config validate schema.yaml. So if you are making any changes in the rules over here, you essentially need to like lint that if the changes you have made are compliant to what like linkml's standard are. So as of now it would all pass because we are not changing anything in our like Bilayers spec. But just like as of now we are not focusing here, so it's okay, just like validating this is fine. Now after this, once you have completed all these three steps, now you put in your algorithm into CI/CD stuff, and that builds out Gradio interface, Jupyter Notebook interface, and then CellProfiler plugin. So the fourth step would be changing some CI/CD stuff where um, you make some changes in the script folder. So now moving on from source to scripts thing, which has built Docker script file, we are adding our algorithm here. So it already has star inference, but I'm saying star. It already had StarDist, but I'm tweaking this as star inference thing. Um, now just like build the script executable and then run the build script, which would translate into uh, all the interfaces. Those would be generated inside the source folder build structure here. There would be generated folders created, which would have your algorithms folder name. App.py is the code for Gradio uh, interface. Generated notebook.ipynb is for Jupyter Notebook, and then CellProfiler plugin thing. So now I am going to my Docker. It should have built one Docker for this star inference Jupyter image. Wow. And star inference Gradio image. They are recently created just now. Um, once it's stopped, okay, it is. I would try to run those things if that works perfectly. For Gradio, you essentially I give port 8000, but you can give anything. Then putting in our image, essentially keeping this all same. And then if like checking if our files which came out have the correct output or not. So this is recently generated file and it has correct output, I believe. And the probability map. So now checking the output for Jupyter Notebook. So spinning up this container, star inference Jupyter image, but Jupyter Notebook, Jupyter interface would like you to have volume mounted stuff. So you need to specify, and then okay. I'm just checking if my output folder, which I want to give star stuff, has. I'm cleaning up this thing. So
Anyone else feel like we live in the frickin' future? Because I feel like we live in the frickin' future.
Mind blown. Rajavi, this is like not possible. But it is because you did it.
and then spinning thing. It has our, I'm just checking. It's volume mounted. It has both inputs and output folders. This is Jupyter Notebook, essentially. Um, all the beginner and advanced mode are here. You don't need to put in images because they are already, but then I am changing some pre-trained 2D demo thing here. Um, I would also like to have probabilities saved, and then this would give you what argument is built in the backend and how it's running. So and the third cell executes your CLI command, and now output folder should have whoa, it has all the outputs. Fair. And now then switching over to CP plugin. So essentially you would just like drag this file to active plugins directory, but I'm copy pasting here. So the CellProfiler plugin.py, I'm just copy pasting and then going to uh, um,
Like the numbers of dozens, if not hundreds of hours we have spent like doing some of these things one at a time, individually.
This is like pure madness. It's I just can't believe this is possible. You are a wizard, Rajvi. Like you're an insane genius leader, Beth. Like I'm sure, I know Nadar, you also had a strong hand at like you guys are this is mind blown.
this is I mean all credit goes to Beth and Nodar, but okay.
No,
Nope, nope,
incorrect, false.
no, that is not true.
And then this plugin I have pasted run star things in active plugins directory is run star.py. Now spinning up the cell profiler. Yeah. And then checking if run star is present or not. Okay, it is. Um, great. Then I would give mm, yeah s1 dot sample here. Um, and then runs. I would choose DNA as my input image because as of now, CellProfiler plugin is volume mounting stuff in a data directory. So essentially, when you make the Docker path, you would need that, folder path as data inputs image. So changing those things here, I think rest of things keeping it as default and then um, running StarDist thing. Yeah.
What? It did it. It worked. What?
It made a self-profiler plugin for a deep learning model.
What? What? Oh my gosh. Wizardry.
Yeah, essentially that is all, and I'm glad that I completed that in time. So, any questions? Yeah.
Questions, comments, things for please make my thing next.
Just to say thank you to Rajavi.
Yeah.
It's very impressive.
Yeah. The hardest part, the part we still can't offload is you need to actually understand how the tool works. But,
Oh.
at some point somebody has to do that anyway. But now you only have to do that once. Just get everything.
So what you showed us right now, it was for generating for the stuff for inference, and you also mentioned that like Bilayers is also like able to generate a separate set of stuff for training the models, right?
Yeah,
Y-
I mean, it should. We haven't tried any training stuff, but Gradio
mhm,
and Jupyter Notebook would like work seamlessly. I
mhm.
haven't looked into CellProfiler plugin stuff if there is anything related to training need to make.
I mean, no, I don't think it makes sense to make CellProfiler plugins for training, right?
Oh, yeah,
So
then for Gradio and Jupyter, yeah.
so
That's it.
you
Yeah.
so you can use that also to like create the interface for train your thing, and then suddenly you have a CellProfiler plugin that runs on a custom model.
Yeah.
That's nuts.
I was going to say, do instance segments.
We already have instance eggs, Gradio and Jupyter Notebook version of the Docker on Bilayers Docker Hub. Um, but the CellProfiler plugin thing is still remaining. And also, we have some bug reporting and things on GitHub. So in case if you guys try out, I just wanted to point that out. Like, okay, where am I looking? Um, feature request. So yeah. So in case like if any bugs come up, or then if you have any feature request, we would like to have all here.
We do also have in the discussions running lists of interfaces we might want to make and things we might want to wrap. So you can feel free to hop into any of those. They're in discussions, not issues.
Oh yeah,
Anytime, let us know.
yeah, here.